Okay, on this problem, we're asked to use the shell method to find the volume of the solid generated by revolving the regions bounded by the curves and the lines and the y-axis. So we're revolving about the y-axis. We have y equals x squared, y equals 6 minus 5x, x equals 0, and x greater than 0. So I went ahead and graphed them, and I'm going to take this off right here just so you can kind of see, probably from a basic algebra class, you would remember y equals x squared is just our parabola. Y equals 6 minus x is our line. Of course, the line x equals 0 is just going to be the y-axis. And we do want it for x greater than 0. So if you start just by saying restricting for x greater than 0, you can see how that looks to try to get an idea. That's not going to be quite what we want, but I'll show you. And then this x greater than 0, obviously, they want the y to be greater than 0 too, so you can say for y greater than 0. Because they want a region, you got to find that region. And then if you're feeling crazy and you want to get rid of this red part that extends, because it's going to be this little sort of, whatever that shape is, kind of a triangle that's cut off with this bent part right here. If you want to get those off, you can say, okay, well, I just want to take it from x equals 0 to wherever this intersects. Unfortunately, in Desmos, you can just hover over where it intersects, and it'll tell you. So you really want to restrict this between 0 and 1. So I can say 0 is less than x, which is less than 1. That just gets you that little piece. Oops. And then same here. I'll just copy that. And then you can get that little piece with the 1, 1. Okay, now if you were on a desert island, or if the point where they intersect was not pretty, it was maybe a square root, you had to use a quadratic formula to solve it or something like that, and they wanted an exact solution, I just want to review how to do that. So to find that point of intersection, you would take your two sections, so your x squared, your two curves, and your 6 minus 5x, and you'd set them equal to each other. So in this case, when you have a quadratic with a middle term, you're going to make it equal to 0 in order to solve it. And then this one factors quite nicely. That would be x minus, let's see, what is that? That's going to be, so x minus 1 times x plus 6, however you factor. And then you'll see that either x equals 1 or x equals -6. So they also intersect over -6. If you went over in the second quadrant, but they wanted it for x greater than or equal to 0. So that's how we knew that we were just going to take this point of intersection. Okay. Now we're using the shell method and we're revolving around the y-axis. And so a key idea that's different when you're using the shell method is that your axis of revolution, if you're revolving around the y-axis, then you're going to integrate with respect to x, because you're going to start here and then you're going to expand out. So you're going to expand out along the x-axis. So again, you're going to think of your shells kind of like if you picked a shell here, and you're going to revolve that around the y-axis. So I didn't actually draw my revolution shape in, but it's that whole shape revolved around the y-axis. So we do have a formula for this integration. It's going to be the integral. The volume is 2 pi times the integral over the region times the shell radius times the shell height, and then dx. In this case, dx, because we're revolving about the y, so we're expanding our shells out along the x-axis. So in this case, we'll start at the y-axis, which will be x equals 0. So we'll integrate from 0, and then we will extend out to 1. We'll stop when x equals 1. We have our 2 pi in front. Our shell radius is just whenever you revolve around the y-axis, the shell radius is just x. That's that distance, just this distance right here, right? That radius right there. It's not very pretty, but that from the y-axis to the curve, that radius is just x. This is how far you've gone in the x. And then the height is just the difference between the two curves. It's just going to be the length, the difference between those two curves. So in this case, that is going to be the top curve, which is 6 minus 5x. minus the bottom curve, which is your x squared, and then dx. And if you wanted to do this by hand, you could, of course. You'd have 2 pi. You'll integrate from 0 to 1. You would want to expand this out. So this will be 6x minus 5x squared. And then minus x cubed dx. And then you'd have your 2 pi. Hold that up a little bit. Expand this a little bit. And that would go ahead and integrate. So 6x antiderivative is going to be 6x squared over 2, which would simplify to be 3x squared minus 5x cubed over 3 minus x to the 4th over 4. And you're going to do that from 0 to 1. So then you have your 2 pi. Fortunately, we go from 0 to 1, so when we plug in 0, we're going to get 0. But this will be 3 times 1 squared minus 5 times 1 cubed. These are nice numbers to have to do by hand, aren't they? And then minus 1/4, or 1 to the 4th over 4. And then minus, when I plug in 0 in each of those, I'll just get 0. And, oops, always wants to do this. Coming down here, we'll have the 2 pi. And then this will be 3 minus 5/3 minus 1/4. How old school are we going to be here? Are we going to go for it? Let's do it. It's Saturday afternoon. Can I do fractions? So our common denominator will be 12. So that's going to be 36/12 minus 20/12 minus 3/12. So 13 is what we get there in the top. So 2 pi times 13 over 12. And then 2 goes into 12 6 times. So this is 13 pi over 6. Now, just as a reminder, you can't always check these with Desmos or do them if you're not feeling like doing the fractions, because I'm not actually checking to see if you can do fractions. If you typed in the integral, you're not going to want to put the pi in because they want an exact solution on this one. So you can put the 2 in the front and just remember to put the pi at the end of your answer. So you're going to go from 0 to 1, and then parenthesis, okay, the shell radius, which was x, times the shell height, which was the 6 minus x, 6 minus 5x, and then minus the x squared. And then close that parenthesis, and then close this parenthesis, and then say dx. And then if you click on this little rectangle right here, it'll make it a fraction for you. And then just remember to plug in your pi.